Alright, so now I thought we would do another video, hopefully you're not getting tired of them, of a simple circuit where you have two voltages that are of big interest. So we're going to measure them with the oscilloscope in roll mode. It's just rolling. We set it so that it doesn't scroll too fast, and we DC coupled it so we can look at DC voltages for the most part. So let's kind of do a demonstration. This switch is being finicky right now. There we go. Once I got a good connection of the switch, output went high and capacitor started charging, and now it went back to the stable state. The output's low, capacitor is discharged, and it's going to stay like this. That's why it's monostable. There is one stable state. We got channel 1 here. That's the yellow line, and that's the probe. It's hooked onto a little jumper that's on the board. You can't see it there, but in any case, you have to ground both of these probes. So here's channel 2 probe, and it's grounded to negative supply. It's got to be the same voltage. That's measuring the capacitor there. So we are going to start the process again, and keep an eye on it from back here. You can see the red LED lit up. Then it turns off, and the blue LED lights up when the output goes back low. So that's stable. That's not the stable state. That's the timed state right there. Monostable, one stable condition for this circuit. So we're going to zoom in, and this circuit's covered in a lot more detail in other videos. We're not going to worry about it too much, other than I'm going to mention we're working with 5-volt power supply, 1, 2, 3, 4, 5, and the most 555 timers are single supply integrated circuits. So they fall short of the positive supply, usually at least a volt right there. That's common with single supply components. Whereas the output does go to ground. And so that's basically what single supply means. Now, the capacitor. So it's falling short of the supply voltage, but that's because that's the way the 555 timer works. When the output goes high, the capacitor starts charging. And so the timing is determined by the resistor and the capacitor value. So this is a 100 microfarad capacitor. If I had a 10,000 ohm resistor, it would take about 1 second. So I used almost a 50,000 5 times to get us about 5 seconds. And it should fall a little short because it's a 47,000 ohm resistor. But that sets the timing. And in any case, we got about 5 seconds, which is what I was aiming for, about 5 seconds. For some reason, it took a little bit longer. But you notice we got 5 volts there. That's about 1/3 of the supply voltage, and that's about 2/3 of the supply voltage. When it hits that point, the 555 timer stops letting the capacitor charge. It actually connects to ground and instantly discharges the capacitor. Any current through the resistor also goes to ground. So it's kind of like a switch that switches to ground. At the same time, the output goes low and stays low in its stable state. So that's how the voltages of the 555 timer in monostable mode works. So we're not going to discuss the circuit in great detail. That's covered in a lot of videos, but the waveforms there are not shown in a lot of videos, but they don't need to be. Once you understand that waveform, output goes high while the capacitor is charging at 2/3 supply voltage, and then they both drop down. Once you understand that, when you see the physical circuit or schematics of the circuit, it's even easier to see in schematics, you can understand what those voltages are doing at the same time. You don't need to actually see the waveforms anymore. This should be burned in your head probably permanently now. So hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They'll help out a lot. I'll see you in the next video.